Hello friends, welcome to Independent Learning. My name is Raj Shah and in this video we are going to continue with the chapter circle. Okay, in the first video we saw the introduction of the chapter circle. Okay, in the second video we saw some properties of chords. Okay, and here in this video we are going to see some properties of congruent chords, meaning if two chords, if they are congruent, what are the properties that comes in the picture. Okay, so there are some theorems. Okay, let's see them one by one. So the first theorem, which says congruent chords of a circle. So here first of all the chords are congruent, AB and CD, they both are congruent. Okay, congruent chords of a circle are equidistant from the center of the circle. That means if there is congruent chord, okay, then okay, those chords, okay, this chord AB and CD, they will be at equal distance from the center. The center is O. We'll just write it. We'll write the given part. O is the center. Okay. AB is congruent to CD. You can say chord AB is congruent to chord CD. Okay. Now what are we supposed to prove? That, and also before writing OP, okay, OP is what? Perpendicular to AB, because this is what? It's a line, a segment which is which is a perpendicular on chord AB. Same way OQ is perpendicular to chord CD. So that can be written OQ is perpendicular to CD. So this is what is given now. Okay. Therefore, if this is the perpendicular, you know AP is equal to BP, and if OQ is the perpendicular on chord CD, then DQ is equal to QC. That is the previous theorem which we did. Okay, it's based on that, because if there is a perpendicular drawn on the chord from the center, then it bisects the chord. So we say the theorem is perpendicular OQ, okay, perpendicular drawn from the center of the circle to the point on the chord bisects the chord. Okay, so I hope you can check the video, the previous video on this. Okay, now so this is given to us. We are supposed to prove, what are we supposed to prove? This OP is congruent to OQ. Why? Because we have to say that congruent chords, okay, congruent chords AB and CD are equidistant from center. So OP and OQ, they should be same, means congruent. They should be equidistant, meaning they should be equal or congruent. Okay, this OP and OQ. Therefore, this is what is given and this to be proved. So we have done a construction which says OA joining AO and OD. So we write that construction join radii OA and OD. Okay, so we have done OA and OD, we have joined. Okay, now what are we supposed to prove? OP should be congruent to OQ. Now before proving these two to be congruent, can we prove that this triangle and this triangle to be congruent? If we are able to prove this triangle and this triangle to be congruent, we will be able to easily say that OP is congruent to OQ. Yes or no? So let's approach. Let us start with the proof with this approach itself. So we'll see proof in triangle, or you can say this is a right angle triangle. Okay, so this triangle is a right angle and this is also a right angle triangle. So we'll just say in triangle OPA and triangle OQD. Okay, so you have taken these two triangles. Now see, this is congruent to this because radii of the same circle, correct? So we'll say OA is congruent to OD because radii of the same circle, correct? Now if you see, can sorry, can AP be equal to DQ also? We'll just find that out. Okay, we'll say, see, you know, AP, okay, AP is half of AB. Why? Because AP and PB, they both are equal. Okay, so AP will be half of AB, and also we can say DQ is DQ is half of DC, correct? Now if you see AB and DC, see, they both are congruent. Therefore can we say therefore we can say that if AB and DC are congruent, that means if I write AB as 2AP and DC as 2DQ, therefore if these two are congruent, therefore we can say that 2AP is same as 2DQ. 2 gone, you get AP equal to DQ, correct? So this is given to us, sorry, AB is congruent to BC. Okay, so this is given to us, therefore 2 gets cancelled, you get AP is congruent to DQ. So this can be done before writing this also, so it's better if you do this before this part. So this is done. Now AP is congruent to DQ also. Okay, let's write this as 1. So we'll say from 1. Okay, therefore if you see OA and OD, they both are congruent, means the hypotenuse is congruent. Okay, and one of the side, which is AP, is congruent to DQ. See, so one of the side is also congruent. So we can say therefore triangle OPA is congruent to triangle OQD by hypotenuse side test. Okay, so I hope you understood. We proved these two triangles to be congruent. Therefore we can say that, okay, right after this step we can say therefore OP is congruent to OQ. Reason for this, CSCT, corresponding sides of congruent triangles. Okay, so it's easy to understand. I hope you have understood this. We proved these two triangles to be congruent. Before proving the two triangles to be congruent, we proved that this AP is congruent to DQ, so that we get one of the sides to be congruent, which will be used in this. Proving the two triangles to be congruent, it will be used in this. So we do this part before, and then we do this part, and by CSST we prove that OP is congruent to OQ. Okay, so here's this proof. Now let's see another. Now this statement, it's just the converse of this statement, which says that the chord of a circle equidistant from the center of a circle are congruent. Now what is it saying? The chords of a circle, okay, equidistant from the center. So this, okay, OP and OQ, they are equidistant. It is already given to us because this theorem which we are taking is converse of this which we proved just now. So here in this theorem we proved OP is congruent to OQ. We had to prove. But here in this theorem we are saying that OP is congruent to OQ. And what are we supposed to prove? That the chords are congruent. Earlier in this proof we took two chords to be congruent, and we proved that OQ and OP, they both are congruent. But here what are we taking? This OP and OQ, okay, the chords of a circle equidistant from the center, they both are congruent. If they are congruent, then the chords which is AB and CD, we have to prove that it is congruent also. So this is what it says in this theorem. So what are we supposed to do? What is given here is, I'll make changes for this itself. Okay, so we have to prove AB is congruent to CD. Okay, we need to prove the two chords to be congruent, and here OP is congruent to OQ, it is already given, and the rest everything remains the same. OP is perpendicular to AB and OQ is perpendicular to CD. Okay, so this is what it is, and this construction remains the same, which is this joining the radii. Okay, and then here you can write the construction. Then in the proof, I hope you will be able to do the proof. I won't be showing it here. It's pretty easy. What you are supposed to do is again prove the two triangles to be congruent, and using this, what you call it, same way like this. Here we used AP. Okay, we used AB and DC, and we proved that AP is congruent to DQ. Correct? Now here in this theorem, we'll use AP and DQ, and we'll prove AB and DC to be congruent. Okay, so I hope you'll be able to write this proof. Okay, we'll do some questions based on these two theorems. Okay, and we'll end this topic here. So so I've taken two questions here. Let's see for the first one. It says O is the center. Okay, AB, the chord AB and CD, they both are congruent. This OP distance is 4 centimeter. Okay, OP is perpendicular to AB and OQ is perpendicular to CD. Okay, so this diagram, it somewhat looks like looks like the similarity. It is similar to the theorem which we saw. Okay, so let's find OQ. Okay, here in the solution part, OP is given as 4 centimeter. Okay, and this two, OP and OP is perpendicular to AB and OQ is perpendicular to CD. This is also given to us. Therefore, I would say OQ is congruent to OQ is congruent to OP. Why? The reason for this will be OP and OQ. So what will we say? Congruent, we just did the theorem based on this, that says that congruent chords of a circle are equidistant from its or from the center. That means if the chords are congruent, then the distance between the chord and the center of both the chords and the center is same. That means OP and OQ is congruent with the help of this theorem. Okay, therefore we say, OQ is 4 centimeter. Okay, so this was the first one, easy one. Okay, let's see the second one now. It says PM, this PM and PN, this is chord PM and chord PN, they both are congruent. It is given to us. We have to prove that PC is the bisector of NPM. So I have drawn the diagram. Now if you want to prove PC as the bisector, that means this ray PC, it divides these two angles into equal parts. Correct? That means if you want to prove PC is the bisector of NPM, that means we have to prove that these two angles should be congruent. If we want to prove these two angles to be congruent, first we need to prove these two triangles to be congruent. If we are able to prove these two triangles to be congruent, then we can say by CACT that these two angles are also congruent. If these two angles are congruent, then we can say that PC is the bisector of NPM. Okay, so that's the approach how we'll be solving. Okay, let's see the proof now. Before doing the proof, we constructed something, so let's write that. Join. So this is radius CM and CN, therefore join radius CM and CN. Okay, now let's see the proof. Okay, so we'll consider the two triangles in triangle. So what are we considering? MPC and triangle NPC. So we have considered these two triangles and we have to prove these two angles to be congruent. So let's see how we do. So now here PM is congruent to PN. Why? Because it's given. It's given that the chords are congruent, correct? Now I can say MC is congruent to NC. MC is congruent to NC. Why? Because radii of the same circle. Yes or no? Therefore, radii of the same circle. Now we can say PC congruent to PC. Why? Common side. Correct. So we have got three things to be congruent. Therefore, we can say triangle MPC is congruent to triangle NPC. Why? What test? SSS. Why? SSS test. These two triangles are congruent. Therefore, we can say angle MPC is congruent to angle NPC. Correct? What will be the reason for these two to be congruent? Again, CACT, corresponding angles of congruent triangles. Therefore, if these two angles we have got as congruent, we can say that PC is the bisector of angle NEM. Okay, so I have told you as earlier, if these two angles are congruent, that means what is the meaning of the word bisector? That it divides equally. So if PC has to be the bisector of angle NPM, that means it should divide these two angles in equal parts. So if we are proving that these two are divided into equal parts, see, MPC and NPC, they both are equal. If these two angles are equal, that means that PC is the bisector of this angle NPM. Okay, so I hope you have understood this. Easy proof for you, was an easy sum. Okay, so I hope you are understanding my videos. Okay, so this is the end of the chapter. Share it with your friends. Okay, and thank you for watching.